Hello and welcome to our continuing series on machining fundamentals. Today we're actually going to be able to make some chips. We're working with the lathe once again today, and we're going to be making this part right here. But to get started, we need to do some setup. So with our lathes here, you'll notice we have a table right next to each one. These have tools that we use all the time with the lathe. I have my cutting tool right here. I have my wrench for tightening the quick change tool post. We'll get to that in a second. I have specific Allen wrenches that we need for setup on the lathe. I have my drill chuck, and I have my machinist 6-inch rule. These should be all the tools you need to do setup on the lathe. And there's a reason why this wrench is so short. You do not need to over torque things, and there's a reason we only provide 2 Allen wrenches with each lathe. We don't want people grabbing the wrong Allen wrench and stripping out nuts, etc. So we're going to do a setup using just these tools right here. And to start with, we're going to install our cutting tool. The first thing I need to do is put the tool in the tool holder. And remember, this is a quick change tool holder. So once I get everything set up the way I like, I can remove this and put it back in as necessary to change out tools. So I'm going to put my tool in the tool holder right like that. Now there's lots of options. I could have it sticking all the way out. I could suck it all the way back in. I could kick it at an angle like this, or I could have it flush against the back of the tool holder. The things you're looking at when you're deciding how you're going to do that are 2, flexibility and rigidity. In general with machining, you want to keep things as absolutely rigid as possible. So as rigid as possible means I would have minimum stick out, and I would have this pushed right up against the back of the tool holder. So I could tighten it down right like that. Now that would give me a very rigid setup. I would have the best chance of getting good surface finish and taking deep depth of cuts on the lathe, but it wouldn't give me a very adjustable or adaptable or flexible tool. So the opposite of that would be I could slide this all the way out here. Now I have greater reach with my tool, but less rigidity. I could kick it out at an angle like this. Maybe it lets me get closer to the chuck while keeping the tool post farther away from the chuck. But here I have the absolute minimum rigidity possible with my tool. So in general, I'm going to put the tool short and tight up against the back to give me the most rigidity possible, and then adjust it if necessary as I'm cutting the part if I need to give it more stick out. Once we have our tool in our tool post and our tool holder, we have the stick out that we like. We need to adjust the angle of the tool post. The purpose of adjusting the angle of the tool post is so that the tip of our tool is the absolute farthest part in both X and Z. If we had, for example, and it's going to be hard to do this with this tool, but if I had it set up so that the tail of the tool is farther out than the tip, as I take a turning pass, it's going to drag the tail of the tool across the part and give me bad surface finish and a big fat cut. If I have it like this, where this part of the tool is sticking out farther than the tip, then I can't make square shoulders because this is always going to make an angle on the shoulder of my part. So I'm going to adjust my tool post such that this tip is farthest out and this face recedes back and this face recedes back. And then I'm going to tighten the quick change tool post like this. I don't need to reef down on it, I just need it tight enough that it doesn't move. Now the mistake that some people make is they think they need to adjust the compound to adjust the angle of the tool post. You don't. The compound, you're adjusting the angle of travel of the compound. It's not for adjusting the angle of the tool. This way I can refine the angle of the tool all the time without messing with the compound. Now that we have the angle of our tool set, we need to set the height. The height is probably the most important part of setting up our tool. And it's something you should check every time you approach a lathe and start cutting if you haven't inserted the tool yourself. The reason is, if the tool is too low, it can dive under the part and cause a crash. If the tool is too high, it's just not going to cut and you're going to get very bad service finish. The tool height is set by raising and lowering the holder on the quick change tool post, and it has these two nuts to keep it at the height and this one to lock it in place. What some people do to get an approximate height set for their tool is to use the tailstock as a guide. They back their carriage up here so that they can eyeball up against the tailstock. We know that the tailstock center is always at the dead center of our chuck, so it's always going to be at the dead center of our part. So we can eyeball our tool against this tailstock center to make sure that it is on height. To get it more accurate than that, we're going to have stock in the chuck. So let's do that next. So now we are putting our stock in the chuck. I have my stock here. It is about 3/4 of an inch in diameter, and I'm putting it in the 3-jaw chuck. The advantage of the 3-jaw chuck is it's self-centering, so we're not going to have to get it on center. We're just going to put the stock in here and tighten it down. Things to be concerned about when putting it in is that it is far enough in the chuck. We wouldn't want to hold it all the way out here, holding on to only 1/2 inch and sticking out this far. If we did, we would need to support it with a tailstock center. So we're going to want it far enough in so we have full chuck jaw grabbing onto it. General rule of thumb is you could have your stock sticking out 3 to 5 times the diameter of the stock, and that is max. 5 times, that might be a little bit much, and you'd probably get some bad service finish due to flexibility on your stock. But 3 times is easy enough. So I have this sticking out about 2.5 inches, which seems about right. So I'm going to use my stock to check the height of my tool now. To do that, I'm going to bring the carriage over. I'm going to grab my 6-inch rule, and I'm going to gently pinch it between the tool and my stock. And what I'm looking for is if the ruler is vertical. So it's always helpful to come around to the very back of the lathe and look to see if it is vertical. And if it's not, I am going to loosen the nut here. And in this case, I think it was a little bit high. So I'm going to turn this here, and then I need to loosen the handle and let it drop down. And then I'm going to gently feed it back in with the cross slide, and once again, look from the back of the lathe. Now it's too low, so I'm going to back off. I'm going to loosen the handle. I'm going to tighten this nut, tighten the handle. Once again, pinch it gently. And now it is vertical, so I know, because of geometry, that my tool is on center of the part, and I'm going to slide this nut down to keep it in place and remove my 6-inch rule. Now there's one other way to confirm that this tool is on center, and that is when taking a facing cut, if that tool is not on center, it's going to leave a mark in the middle of that part. It's going to leave a little nib. And oftentimes the first thing you're doing when taking a cut on a lathe is facing the stock to length. So when you're facing the stock to length, you want to look for a little nib like that. And if you see a nib, your tool is either too low or too high, and you need to adjust your height to get rid of that nib. So by roughing it in with the tailstock, by using a 6-inch rule to check it, and finally by taking a facing cut, you should be able to tell that your tool is on center. Let's talk about speeds and feeds for just a second. There's a cutting speed formula we use. It is 4 times the surface feet per minute divided by the diameter of the part. The surface feet per minute is something, with a lot of cutting tools, you would just get from the manufacturer. Otherwise, there's rules of thumbs that we use for different types of cutting tools. High-speed steel versus carbide and the like. We'll have another video where we'll go into more detail on speeds and feeds. One of the nice things about our earlier projects is we have setup sheets in the back. And this is going to tell us what our speeds and feeds are. So we don't have to really understand those formulas at this point, and we could just go with what's on the setup sheet. So I need to turn the lathe on. Do right like that. I'm going to make sure that I'm feeding towards the chuck. From my setup sheet, I know that I want to be turning at 450 RPM. So to get to 450 RPM, I need to shift this over into high and make sure that's in gear. I'm going to be using a feed rate of 7 thou inches per rev. So I'm going to look on my chart right here, and that's right about here. So that's AC and PV. So if I look down here, I've got AC, that's P, but I need to get this all the way over to V. Doesn't want to go, so I can either use a jog or I can just rotate the chuck with my hand. So now I know I'm feeding towards the chuck, I'm in high gear, I have my feed set up the way I want, can close the chuck guard. And we're right around 450 RPM. To start off, we're going to face our part to clean up the saw cut edge and establish our Z0. It's important when doing this to move gently into the part. What I tend to do is move right up against the part. What I tend to do is move right up against the part, and you can almost hear it before you see it. I can hear it start to cut. I then back out with the cross slide, move in a tiny bit more, and for this first cut, I'm going to feed by hand with the cross slide. I don't need to use the power feed for this. I'm moving in nice and slow, and then backing out. If we take a look at our part, we'll notice we left a little tiny nib in the middle. I can move back in and realize that my tool is moving below that. So I'm going to back this off, turn this just the tiniest little bit, and back out, and take another pass. And this time we knocked the tip off, so we know that our tool is on center. I'm going to move the carriage a tiny bit closer, and this time I'm going to use the auto feed to feed across the part. Auto feed gives us a nice smooth finish for the end of our part and establishes our Z0. Once all the way across, we back out by hand. Now, one thing that I've done here, which is very, very important, is I did not move the carriage after taking this facing pass. I just backed out with the cross slide, because what I'm doing is I'm establishing the Z0 on my part, and I need to do that when the carriage has not moved. So at this point, I'm going to reach up to my digital readout and zero my Z. You'll notice on this digital readout, we have some LEDs across the top here. We want to make sure the LED on top is pointed to 0, and then I can just hit the button next to the Z, and notice it zeroes the Z. At this point, I can move my carriage wherever I want because that Z0 point is remembered by the DRO. The next step is going to be to do essentially the same thing. We're going to take a turning pass, and we're going to zero out the X. So now that we have touched off our Z, and we've established that this face is Z0, we need to do much the same with our X. In this case, what we're doing is we're establishing the diameter of the part. Now we know that this stock is about 3/4 of an inch, but that's not accurate enough to go by. So what we're going to do is we're going to turn a diameter that gets underneath the mill scale of the part. We're then going to measure that diameter and zero our DRO all at the same time. So much the same we did with the Z. We're going to gently move in on the part until we hear it touch and see it touch, move off the part, and then we're just going to take a very shallow cut, something around 15/1000ths of an inch. And in this case, I'm going to use the power feed for this. Just like with this, when we established our Z, but this time with the cross slide, I did not back the cross slide out when I backed off the part. I want the cross slide to be in the exact position it is when I made this diameter. I want to make sure that I cut all the way around the part, that I don't see any part that was left of the mill scale or any unmachined surface. At this point, I can measure this diameter. And I have about 741 thousandths of an inch. And I'm going to zero my DRO. There we go. This is the part where we need to plan out our turning operations. It's the only way to ensure that the part will come out on size and with good service finish. What do I mean by plan out our turning operations? Let's go through it. We just measured the diameter of our part. It's 740 thou. Looking at our drawing, we have to take it down to 600 thousandths of an inch. That means that we need to remove 140 thou off the diameter to get to that size. I suppose we could just dial in 140 thou on the cross slide and let her rip, but I think you and I both know that that isn't the smart way to do it. So what is the smart way to do it? The smart way to do it is to take a series of cuts, measuring after each one to check the size of the part and adjust as necessary to bring the part to diameter. Now you may be thinking, why do I need to measure after each pass? Doesn't the DRO tell me the size of the part? The simple answer to that question is no. The DRO tells you the position of the cross slide, but what it can't tell you is how much material the tool actually removed. All machine tools flex. All parts flex. Nothing is perfectly rigid. When you take a cut on the lathe, the part flexes away from the tool, and the tool flexes away from the part. This means that just because you move the cross slide some distance, the tool might not remove that much material. Your job as a machinist is to pay attention to this situation and adjust as necessary. The best process is to turn your part to the finished diameter with 3 passes of the same depth of cut. A depth of cut that you think will give you good service finish and very little flex. For this part, I'm going to finish the diameter with 3 passes of 20 thou each. I say 20 thou, but what I really mean is approximately 20 thou, because I'm going to measure after each cut and make adjustments. My last pass might be 19 or 21 thou as necessary to hit the 600 thou final dimension. Okay, so now that I've decided to take 3 passes of 20 thou to finish my part, for a total of 60 thou, and I have 140 thou to remove, that leaves 80 thou more to take off. I'll do that in 2 roughing passes of 40 thou each. So my plan is now to take a total of 5 passes. 2 roughing passes of 40 thou each, and 3 finishing passes of 20 thou each. There's other ways that this could be done and achieve just as good of a result. You could take 15 thou finishing passes and take more off while you're roughing. What's important here is that you plan your operations and measure regularly. Try to take consistent passes of the same depth and feed rate so you can predict what the next pass will do. Whatever you do, change things as little as possible on your final passes. One thing that I like to do is give myself a mark. I'm just going to use my 6-inch rule here, and I'm going to mark 1 inch on my part. Now that's a very approximate measurement right there. And I can take and rotate the chuck while holding my pen in place. But that is just to give myself a witness mark to machine up to. This way I don't have to keep looking up at the DRO as I am turning my diameters. I can just look at that mark, and as I'm getting close, I know to pay attention to the digital readout. So let's give that a try. I'm going to dial my cross slide in 40 thousandths. And engage my feed. I'm watching my line, and I'm going to stop short of it. And if we look at the DRO, I'm about 40 thou short of my 1 inch. So I'm going to manually feed right up until about 15 thousandths short of my 1 inch. Somewhere right around there. Now I can back out. And let's measure and see how I did. Really close. So I'm at 700 thousandths, which is exactly what I expected. So let's take another 40 thou pass and do the same thing. This time I have a nice shoulder that I can watch, but I'm still going to look at the DRO when I do my last move up to that shoulder. Measure again. It's looking pretty good. We're at 660 now, and we're shooting for 600. I'm looking at my service finish here. It's not horrible, but I'm going to slow the feed rate down a little bit so I can get better service finish. I'm going to slow that down to about 4 thousandths per rev. And we're going to do our 3 finish passes of 20 thousandths apiece. It's important to measure at this point. These final passes are where it all matters as to whether we're going to hit our diameter. So I'm about 1 thousandth under. Actually, I think I'm about right on size. We're now at 640. So I'm going to take that second 20 thou pass and see how it goes. Okay, so after 2 passes of 20 thou apiece, what are we measuring at? We are measuring right around 620 thou. So I think we're doing pretty good. We just need to take 1 more pass of 20 thou, and we should be on our numbers. Now this pass, when I hit this shoulder, I'm going to go right up to my 1 inch, and then I'm going to back out with a cross slide to establish this shoulder. So we need to in-feed to 140 thou. And we'll take our last pass. Now, when the lathe is taking this pass, I have my hands on both handles. I have my right hand on the feed handle, and my left hand is following the longitudinal feed. This way, if anything were to go wrong, I'm ready to take control of the lathe. I also have my foot right next to the emergency brake. I'm not standing back away from the... So now I'm going to hand feed right up to my 1 inch. And I'm going to back out by hand with the cross slide to establish that shoulder. Our service finish is okay. We are right on 600 thousandths. And 1 inch. So there we go. There's the first step of our part. To make our chamfer, we're going to have to rotate the compound. We have these 2 bolts on either side of the compound that hold it in place. Now these bolts go into T-nuts that are in a circular groove underneath the compound. Sometimes they'll get stuck a little bit when you try and move the compound. If they do, all you need to do is maybe loosen them a little bit more, or even sometimes tighten them a little bit more, and it'll allow it to move. What you don't want to do is undo these all the way. If you undo these and remove these bolts, it becomes a huge pain in the butt. So now that we have these loose and it's sliding easily, we can see there's a reference mark right down here on the bottom. We're doing a 45-degree chamfer. I'm going to line the reference mark up with the 45 and then tighten the bolts on either side. They don't need to be super tight. They just need to be tight enough to hold it in place. Now you'll notice that my tool post is at an odd angle. So I need to loosen this, rotate this around, and basically keep it much like we had it when we were doing our turning and facing. We want this point to be the farthest point out, but now on a 45-degree angle here, so that when we're taking cuts back and forth like this, we have our cutting tool cutting appropriately. Now we need to put the chamfer on this part. Looking at our drawing, the chamfer wants to be 130 thou. So that's 130 thou single depth. Because it's a 45-degree chamfer, it's also going to be 130 thou this direction on our part, and it's going to cut across it at a 45-degree angle. I've got my compound set at a 45-degree angle. I've adjusted my quick change tool post so that the tool has a nice angle of attack. So here's the thing. There are a lot of different ways to put a chamfer on a part. I'm going to show you one way to do it. What I am going to do is make a mark very close to my final chamfer distance and machine up to that mark. I'm then going to measure the chamfer, calculate how far I have to go, and finish the chamfer to dimension. Now this mark here is just a reference mark. I'm going to turn this by hand until that mark is gone, and then I am going to measure and take 1 or 2 accurate cuts to finish off my chamfer. So let's back this up. I'm going to feed in a tiny bit with the apron, come across this way. I can feed in with the cross slide, come across this way. It's important to turn very slow if you want good surface finish with the compound. I'll often use 2 hands to help me make this a nice, smooth cut. Jerky motions with your hand at this point are going to cause rough surface finish. I'm into my line. I think this is probably going to be my last pass, and then I'll measure. I have my caliper set at 130 thou, which is the chamfer depth. And I'm kind of using them like a gauge up against here. So another way, besides using your calipers as sort of a gauge to measure, which is more accurate but requires moving the carriage well away from your part so you can get in, is to use the depth gauge on your calipers. So what I'm doing here, and I'm going to do it, see if I can do it so you can see it. I have going all the way up against the shoulder and then all the way up against here. And then I'm going to ever so gently, I'm going to slowly bring it in, keeping it square to the part. I can kind of feel, can definitely see as we hit the chamfer. So we're just a little over 100 thou on that chamfer. So we have 30 thou to go. So call it 25 thou to go to bring that to our final chamfer. Now that we've moved the carriage all the way out, it's a little bit difficult to find that spot again. Think I just hit it? Okay, there we go. I'm going to call that, we'll call that a 3 thou pass. 0 my DRO. So I'm going to go another, we'll call it 25 thou in, but remember the cross slide is reading in diameter, so I'm going to have to go double that. So we'll take a pass at 10 and see how that looks. Back out. We'll go all the way up to 25. And back out. We'll go to 40 and leave us a 10 thou finishing pass. Okay, we're going to call that good. And we'll measure that again and see how it looks. Now, I'll call that pretty good. So there's our part. We've got all the features on it. Let's take it over to the granite and inspect it for real. Boom.